All right, we are going to look at factoring trinomials. Now, there are several different methods that you can do this. The one that I'm going to look at mainly to start is the one that you were introduced to back in Integrated Math 2. In Integrated Math 2, we started looking at the area model and the diamond problem to help us through these problems. So let's start with a problem like x squared plus 11x plus 30. This is a trinomial. It's in that standard form where I have ax squared plus bx plus c. Whenever we're factoring, we want to make sure that it's in the proper order. Now for the area model, remember we start with our area model box, and then I put my first and last term in a diagonal across from each other. I always like to put it in the upper left and bottom right, but you can also put it right here and right here. What matters is that they're diagonally across from each other. The next part is the diamond problem. Remember up here, this is the product of my two numbers. So I have x squared times 30 gives me 30x squared. And then down here, this is the sum, and that comes from this term right here. So I end up with an 11x. Now solving this diamond problem will help us figure out what goes into these two boxes here. I need something that's going to give me a product of 30 and a sum of 11. And I can think about my factor pairs of 30. I've got 30 and 1 and 2 and 15 and so on. But the only one that will work is 5x and 6x. So my 5x goes here and my 6x goes here. The next step is factoring these pieces out. So solving this area model problem, I end up with, not an x squared, excuse me, an x here and an x here, because I can factor out an x in both of those directions. Here I can factor out a 5, and here I can factor out a 6. So I end up with this factorization of x plus 5 times x plus 6. Now, as we continue, our goal is to get away from the area model problem as much as we can. So if I look at this, these types of problems especially, when I see that my coefficient here is just a 1, I just have a 1x squared, I know that I can solve this through trial and error or guess and check. I can kind of just work my way through this problem. And I can figure it out because I know that the only way to get an x squared is an x and an x. So I already have the first part of my binomial. The next piece focuses on this 30. This is a positive 30. That means that I have to have two numbers that multiply together to give me a positive. So both of these signs must be the same. If this number is positive, then I look to this one right here, and if this is a positive as well, I know both of my signs are positive. If this was a positive 30 and a negative 11, then I would have both of them be negative. If this was a negative 30, I would have a plus and a minus. Now I'm going to ask the same question that I asked up here in my diamond problem, but I don't necessarily have to work through the entire diamond problem. Instead, I can think to myself what two numbers multiply to give me 30 and add to 11. And I can say I've got 1 and 30, 2 and 15, 3 and 10, and then I've got 5 and 6. Oh, 5 and 6 are the ones that work. So x plus 5, x plus 6. And I always double check. I've got x squared plus 6x plus 5x. That does give me the 11 plus 30. Yes, that's my solution. So eventually, even though this might be what you're most comfortable with, we really want to get to the point where, especially if our coefficient is a 1 for that x squared, we want to be able to factor these very fluently and quickly. So push yourself to try this method here as much as you can. Let's look at another example. What if I have a problem that looks much, much more complicated? What if I've got something like an x squared minus 2xy minus 80y squared? Now this problem looks very difficult. I've got an x squared, and then I've got an xy, and then I've got this y squared thing. So this problem could make you think to yourself, oh, this is going to be hard. But what I'm going to do is, I notice here I've got an xy, and then here I have a y squared. So it's really, in terms of my variables, it's like I've got a quadratic this way and a quadratic this way. So I know that my solution is going to end up where I've got an x, and then I have some y's and some y's. So initially, I'm actually going to not even consider my y's. I'm going to almost pretend like those y's don't exist. In fact, I'm not even going to pretend, I'm going to rewrite it without the y's. I've got x squared plus 2x minus 80. Now this, change a plus to a minus, there we go, or a minus to a plus. Now looking at this still has that coefficient of just a 1, so I've got an x and an x. What two numbers have a product of 80? But notice this is a negative now, right? So that means I have to have one of them's positive, one of them is negative. So I end up with 8 and 10 because they have to have a difference of 2. One of them's positive, one of them's negative, so I'm subtracting to get a 2. I'm going to put my 10 right here and my 8 right here. And I knew to do that because with this 10, it's negative, so negative 10x plus 8x is going to give me that negative 2 that I want. If this was a positive 2, then my signs would be switched there. Now this is not my answer. However, this is my answer. If I multiply this out, just using FOIL, I've got x squared minus 10xy plus 8xy, and then my last term is going to be minus 80y squared. So when I combine those, I do get that negative 2x squared that I want, and I've got my negative 80x squared. It all works out really nicely. Because of the way I have my y and a y squared, I can really just ignore them and just approach the problem like I would a regular trinomial. Okay. The next one that we want to look at is, what if we have a coefficient of 1? A coefficient that is not 1. So let's say I've got something that looks like this. 8x squared plus 25x plus 3. Now looking at this, if you want, you can try to just figure it out, but whenever I see a coefficient that is not equal to 1, the problem ends up being if I just try and plug stuff in, I don't necessarily know what's going to go here. It's not like I can just guess and check with my last term like before. Instead, I have to try and figure out what goes here and what goes here. It could be an 8x and an x, could be a 2x and a 4x. I don't know what the situation is, so there's more options to guess and check with, which means that it's probably easier and quicker to just go to the area model. And from my personal experience, if I have something that I'm looking at that does not factor nice and quick and simple, I go straight to that area model because it does work out quickly. So they add up to 25x and they have a product of 24, so I'm going to have a 1x and a 24x. Plugging them in here, 24x and a 1x. So I've got 8x and a 1, and then I've got x and a 3. So I've got an 8x plus 1 and x plus 3. So even though it looks slightly different, I did have a coefficient not equal to 1. It still works out nice and quick just using the area model. This method of the area model is sometimes called the AC method. And the reason why it's called the AC method is because this is ax squared plus bx plus c. And really, we are focusing on a and c. That's that 24x squared. Remember, this is your AC. Those two multiplied together gives me my 24. And then trying to figure out what you get for this sum. So really, when they look at the AC method, they're just doing it without the box and the diamond problem. And you can still work through however you'd like. The very last idea that I want to look at is something called substitution. Now, factoring by substitution is when you're looking at a problem that is not necessarily in this form that we're used to with trinomials at this point. We're used to seeing ax squared plus bx plus c. But what if I was to give you a problem like this? X to the fourth minus x squared minus 12. This is a problem. This has an x squared and an x, right? This is an x to the fourth and an x squared. So this doesn't quite give me what I want. However, what if I was to let x squared equal q, some other variable, right? And I look at this x to the fourth. I'm going to rewrite it as x squared squared minus x squared minus 12. Well, since I've rewritten x to the fourth as something squared plus that something minus 12, I now have it kind of in this form. And the easiest way to really see that I still have it in that quadratic form is to actually substitute in this other variable q for my x squared. So I've got q squared minus q minus 12. Now this is a trinomial that hopefully as you work through, you get comfortable and can factor quickly. I've got a plus and a minus because my product is negative. And so I need a product of 12 and a difference of 1. That's going to be 3 and 4. I need my larger number to be negative to give me that negative q. Now this would not be my answer because the problem that I was given is this one right here. So I have to go back and resubstitute in that x squared now. So I've got x squared plus 3 times x squared minus 4. That right there is that factorization. The most important step of this is to be able to write your trinomial in the form of a quadratic. So as long as your exponents can work out, you can substitute in something else and you end up with a nice factorization. So that is factoring trinomials. If you have any questions, please let me know.